This is Michael, and today what I want to go ahead and do is we're going to take a trip down memory lane here. Um, we're on tutorial number 4. If you guys are wondering, man, I looked at some of the other tutorials, he was a little off with the way that he described things. I did that on purpose, and the reason why I did that on purpose is because I want to explain a little background real quick. I teach Spanish too at the university, and so what we do is we go ahead and give people the ability to listen to a language, and we do some things wrong at the very beginning. And the reason why we do is so that they catch other concepts that are more important at the time. And then as they start progressing through the language and are able to see the differences, we introduce those differences. So that's what I'm doing with you, and that's what I did in the other tutorials. Now, we're going to be working with Python here. I opened the terminal, I changed it a little bit. If you haven't started with tutorial number 1, please go there because we're going to be using terminology from those. And if you have a Windows computer, I put some instructions under tutorial 1 because you're going to need to set a path variable inside your Windows environment and do a little download for Python, but it comes automatic for Mac. So open your terminal up, applications, utilities, then go to terminal. Type in Python, P-Y-T-H, talk about binding real quick. And this is what we mean by binding. Last time what we did, and let me go ahead and change the font in this a little bit, just so you guys can see a little bit better maybe. Let's go 18. What I did in this last time is I talked to you about how x is some variable in a table, and how what it is doing is the equal sign isn't really equaling it. What it's doing is it's binding that. It's taking x in some table and it's pointing it to 5. So then whenever the computer sees x, it knows that it uses the other value that it's pointing to. So then we're going to do z. I'm going to equal that to, let's do 6. Then I want to just do a simple equation here, and we're going to do x plus z. Okay, I'm going to go ahead and do this in my terminal real quick. X equals, or not equals, 5 is bound to 5. Z is bound to 6. Okay, so then whenever the computer sees x pointing to 5, it's replacing that variable. Okay, z, and a lot of people make the mistake and they put an equal sign in there. You don't need it. It'll give you a syntactical error because your computer already is making associations based on equations because it's equating. Now it's going to give you 11. Now, what is important and what we're going to talk about today is called branching. Oops, if I can spell. Branching program. What a branching program is something that can change the order of instructions. If you notice last time, what we did was pretty boring. We just did this x plus z, but I talked to you about all the different types, setting integers, doing different things in Python. Now, I want to talk to you about a little bit, and this is going to be the first of them. Let me type this for the people that sent me an email wanting me to type what I'm talking about because they're listening in another language. So first of the conditionals that you are going to see is the if conditional, and this is it's a type Boolean, okay? And Boolean is just the name that they gave to if this is happening. In other words, I'm going to give you this example. If it is sunny, then go outside. Go outside. Else, stay inside. Okay? This is exactly what you're doing with a computer to branch this. You're breaking up the instructions, which before over here were pretty boring. If I had a couple more instructions, like let's say x, then let's say print x, z, 5 and 6. It just printed it. Now that's pretty boring. Now let's say we want to break this up. I want to find the odd value, and here's where you have to start thinking more computer technique. And you have to think the way that your computer thinks, and that's why we talked about type discipline. Type discipline, if you remember, is basically figuring out how your computer looks at it, or not actually your computer, but the language you're using, because different languages look at things different. So that's why you want to go ahead and have some type discipline and figure out what it is that they're asking. Now, I want to make a program real quick, and I'm going to do this real quick. Divided by 2, and then we're going to set that to x. If x divided by 2 is equal to x, then what I want the program to do is print even. Okay? Else, print odd. And you're probably looking at me and you're like, Michael, that's not a good equation. Now, we need to, and this is what you need to keep in, you need to be looking at the way that your computer is computing this. Let's take 3. Let's say x is equal to 3, and we know mathematically that 3 is odd, right? Why? Because arithmetically, my bad, arithmetically, 3 divided by 2 equals 1.5. But your computer computes it as, and we're going to look at that as 3 divided by 2 is equal to 1, because it just wants to know how many times 2 goes into 3, and it only goes in 1 time. This is where we talked about doubles. Doubles and floats. We'll talk about this later. Okay. Now, what your computer really does is it takes this value, 3 divided by 2, and it says, oh, hey, 3 divided by 2 without the float is only 1, times 2 is 2. 2 is not equal to 3, so since it's not, I'm going to print odd, okay? So this is where thinking like the computer comes in hand. Now, I want to tell you 2 equal signs means that the value is equal to the other value. 1 equal sign means that the value is bound. Okay? So we're going to say, here I'm going to bind a value, x is equal to 3. X is a variable in some table that is equal to 3. Z is a variable in some table that is equal to 4. Oh, let's say z is equal to 3. In this case, what's going to happen is, let's say, if z is equal to 4, no, equal to 3, or equal to x, you could do if x is equal to z, that'll probably be better. Print x is equal to z. Now, what's going to happen here is it's saying is the value of it equal to it. It's not saying is x, z. It's saying is the value of this equal to this value. And yes, it is. So it's going to put x is equal to z. Now, what we want to talk about in these if-then statements is that you're going to have some. So really what it is if some test, then you're going to have a block of instructions for it to do. Else, if that isn't, then you're going to have another block of instructions. So if it's sunny, go outside, instructions. Else, stay inside and play video games. Okay, I need to see how much time I have here. Got 8 minutes on the clock. I'm going to go ahead and try to go to the next step. Now, what I want to talk to you about is the indentation way that you're going to be doing this. And this is very important. You need to see how your language works. So we're going to say x equals 15. In this case, we're going to say y equals 5. And we're going to say z equals 11. And then we're going to say print x, y, z. That's what we did yesterday. What's going to result right here is we're just going to get 15, 5, and 11, and you can try that in Python with each of these a separate line. Now, what we're going to do here is I want to add an if clause because I want to make this more fun. And I want to say if x is less than y, if x is less than y, then we're going to, if x is less than z, print x is least. Else, print z is least. else print y as least. Now we have a problem with this, but we're going to work through this real quick. Now what this does, and I'm going to type this out, what this does is if the first, I'm going to move it up a little bit, if the first is true, that x is less than y, then it goes to if x is less than z. If that is not true, it goes to the else print z is least. And if x isn't less than y, then it goes directly to y is least. Okay, this is called, and I'm going to put this is called nesting, okay? Or you can flow your way through. That's what it's called, nesting or flowing your way through. So I'm going to do this a little bit. Is that code correct? No, it's not doing all of the comparisons. It's not doing all the comparisons. I'm going to bring this down just a little bit. I'm going to have to stop in just a minute because I'm going to have to head and teach. It's not doing all the comparisons, and because, let's say this, if you change y and make it to equal to 13, then the code is not correct, which means you need to do comparisons to all of it. Okay? This makes sense? I'm going to give you an example here, and you can back up and pause if you need. Example, and I'm just going to do this real quick and say if x is less than y and x is less than z, print, oops, I should have done this in all over. You guys will have the idea. If x is less than y and x is less than z, print x is least. If means else if y is less than z, print y is least. And else print z is least. Now you see here we have an elif, which is a Boolean combination. It's called a Boolean combination. Means that you can take any logical expressions and combine them with and, or or not. Okay? And these, of course, are of type Boolean. And type Boolean means it can either give you a true or a false. Okay? And I'm just going to end this by adding these. You have branching programs. Okay? Up to this point, though, all you can do is choose which code to run or not. And you're probably like, oh my goodness, this is so much information. It's okay, you need to understand all these basic concepts because when you're building more intricate programs and when you're asking them to do calls on other things and move variables around, you need to make sure if you need to use a certain variable and it needs to be a constant, you need to declare it as constant. If you need something that can be a changing variable, I mean you can take x and put that somewhere else and change that, then you need to do that.